Hello and a very warm welcome to today's webinar, Reducing OPEX with AI-based plant control. Over the next 45 minutes, you will hear how AI plant control enabled by MCube goes beyond traditional automation, leveraging machine learning, multivariate correlation, and autonomous decision support. We'll also take you through real-life implementations, the lessons we've learned, and how to build a roadmap for adopting AI-driven control in your own operations. But before we begin, let me take a moment to introduce our speakers. We have with us today Arunava Mitra, who is Senior Vice President for MCube Platform and Innovation. Thanks for joining us, Arunava. We have Rajeev Limaye. He is Director at Linde Advanced Operations Solutions. Thanks for joining, Rajeev. And we have Neal, who is Advanced Operations Consultant at Linde Engineering. Thanks for joining, Daniel. With that, a very quick guidance for our attendees. This session is being recorded and you will receive the recording post the webinar sometime tomorrow. We have a very interactive audience poll throughout the webinar. So I would encourage all our audience to participate in the poll. And we have a Q&A session at the very end. So all attendees are requested to please put in your questions in the question box that you see on your console, and we will address all the questions at the end. And one last thing, that all attendees are muted for a seamless streaming experience. With that, thank you again for joining us today, and I hand it over to Rajeev Limaye. Rajeev, over to you.
Thank you for excellent introduction. And what I would like to do is give a quick summary of what we are going to talk today. So I will give a quick introduction about Linde. Followed by that, we will have a quick introduction about the MCube platform, and then talk about the Linde's Ignite platform, which enables several autonomous operation applications. And then we will dive into the AI plant control, which is the topic of today, and then followed by that some question and answers. So we will have some poll questions in between. And so to begin, let me give a quick introduction of company. So Linde is one of the leading global supplier of industrial gases and also an engineering company. So this integrated business model of engineering company and operating company is a very unique setup in the industry. We make several industrial gases such as hydrogen, carbon monoxide, syngas, also the atmospheric gases such as nitrogen, oxygen, argon, and supply these gases to our customers through pipeline or via truck or through cylinders. So the company is founded in 1879 with about 65,000 employees today, and we are operating in more than 100 countries. Linde is the largest industrial gases supplier, both by market share as well as by net sales. So 2024 sales of Linde is $33 billion. And we are operating in more than 100 countries. We are operating more than 1,000 plants. And these plants are operated from 7 remote operation centers. So these remote operation centers are located at various locations around the globe. And typically, one operator at this remote operation center has a responsibility of controlling 10 or more plants. So the operator at these centers typically would run these plants based on exceptions. So the operator would respond to the abnormal situations or the alarms, but the advanced applications that are installed and running at these plant locations allow us to operate in this fashion. So many of the advanced automation applications are developed indigenously by Linde, For example, AST is an application that allows the automatic plant startup, which is a very important functions to be able to run in autonomous mode. We have some asset performance monitoring applications such as coil monitor, which is shown here as a picture. It basically using infrared cameras, we can monitor the temperatures of hot coils in a furnace. And AI plant control, which is the next generation of AI-powered model predictive control. We are very excited about this application, which is really proving a lot of benefits to Linde. All in all these applications have proved very promising to reduce our operational expenditures. We could see about 2% reduction in the energy consumption, increase in the product yield. We are able to achieve faster load changes with these applications such as AI plant control, and most importantly, significant reduction in efforts, manpower efforts to maintain these applications. So just to give you the results of what we have achieved in last 4 years. So we introduced AI plant control 4 years ago, and since then it has been running on 5 of our plants in Europe. And AI plant control has significantly reduced our efforts to maintain this application. There is 80% reduction, but not only that, we were able to achieve about 2 to 3% increase in our yield and 1% reduction in energy consumption. This is on top of the classical MPC applications. And we can do faster load changes. So by the end of this year, so we still have 2 months remaining, we'll have a 6th plant fully deployed with AI plant control. And in the next year, we want to roll this application to in the US and to other industries in hydrogen, petrochemical, refining, or natural gases in these markets. So with that, I will invite Arunava to explain about MCube platform.
Sure, Rajeev. Thanks, Rajeev and Aditi both. It is my pleasure to introduce MCube as an enterprise and agentic AI platform, which is powering AI plant control here to all of you. MCube is a platform which is essentially a 360-degree data analytics platform and a platform to build your AI agents and build your models. The platform, from a functional architecture perspective, is comprised of 3 major blocks. One block handles data, which includes very high throughput ingestion of data. It may be structured data or an unstructured data. The storage of data in multi-petabytes, and also creating the different abstraction of that data, including the metric store for easy retrieval, or creating your own semantic layer on top of that data. The second block is on ontologies or semantic layer of the data, where you can connect to any public ontologies even, or build very easily in a user-friendly manner, build semantic layer on top of your data. And the third layer, and most contextual in this in this subject, is the AI block of MCube, which is essentially different available models, 1,000+ machine learning models enabled with MLOps, integrated with MLOps inbuilt in the platform, where you can customize and build your own model, train the models, and even test the models. You can also use the platform to build your agentic, your AI agents. You can also integrate with different LLMs available in the market to achieve your business objective. the whole platform is designed in a very user-friendly manner for data engineers to work on the data block, data scientists and AI engineers to work on the AI block, so that we can achieve the democratization of analytics and AI, what we say. So this is an enterprise grade ready to deploy in production AI platform. It is scalable. It is very, very secure, certified by very strict and stringent security certifications across the globe. It is deployable. It is completely cloud agnostic. It can work with any hyperscaler. It can be deployed in any cloud. It can even be deployed in on-premise if the business requirement is such. It using your AI and inbuilt visualization layer, you can very easily build process digital twins using not only AI models built on the platform, but also with first principle models. So this is a full 360-degree data analytics and AI platform, which can be used as a platform as a service to build the business solutions. In this case, we're talking about AI plant control, of course, and optimization of plant operations. This platform enables your AI plant control models to be deployed very fast in a secure manner and can handle the scalability required for your plants. So I'll go to the next slide quickly. Yeah, so in this slide, I'm going to talk about this collaboration, which you are hearing today between mCube and the Linde's plant operations expertise. So this collaboration essentially is a handshake between best of the worlds. The robust, scalable, secure platform, which is mCube, integrated with or empowering AI plant control, which is built by Linde Engineering's process and operations experts, which are basically people who build real plants, autonomous plants, semi-autonomous plants across the globe, and with all their knowledge synthesized into these models, which will help you to achieve operational excellence in your plant, built and deployed on mCube, which will give you the technological edge. So if you see, we are talking about collaboration at 4 layers or 4 levels. At the bottom, mCube's data capabilities, which I spoke about in my last slide, where it can handle very high throughput of data from your historians, from your control systems, from your sensors or equipments. Then all the models, AI plant control models built on top of this platform by Linde Engineering team, and on top of that, again, giving you access of mCube's ability to develop analytics and optimization and visualization, where the required customization for your sites can be done in a very, very user-friendly and timely manner. And on top of that, the advisory capacities of the deep expertise in this area, the process manufacturing area Linde team has, will play as a catalyst of re-engineering required to deploy these solutions. So this is a winning collaboration, which we think and is already helping a lot of large and major customers across the world to achieve their business objective. So at this point of time, I would like to request all of you to participate in a survey, I mean in a questionnaire, which will be popped up in your screen, because before delving deep into AIPC, what it does and how it can help you, we would like to understand your background a little bit. So there will be 2 such surveys now. One about the industries you represent, and another will be around the job functions you represent. So this is the first one. I would request you to participate in the poll. Okay. We are glad to receive the first poll results, and you can probably see the audience profile of this. So we will try to be very specific on especially refinery, petrochemicals and chemicals, and we'll be very happy to answer questions which are very industry specific or sector specific in your case, because that's the highest number of representation I see in the screen. Can we go to the second poll, please? Okay, so it's very interesting to see that most of the people who joined are from the engineering background, and there are very few operation. I mean, there is almost no operations and maintenance guys. So this thanks for participating in these two polls, because now, as my colleague Daniel will delve much deeper into the concepts of AIPC and how it can help, these inputs given by you will definitely help us to customize how we say and what we say. Over to you, Daniel.
Thank you. So how do we achieve autonomous operations, and how does that relate to AIPC and reducing OPEX? So start by using this slide in architecture to discuss that. I want to first start talking about the AOPS Ignite platform, and then I'll discuss more about the AIPC. So the AIPC, this is our standardized agnostic closed loop control platform. And this is the basis for our fast implementations. It's the basis for our robust solutions. And basically, we don't put together a solution. We use this ready-made platform. And this ready-made platform that we use has 30 plus years of development and experience, along with over 300 implementations. And so, as one would expect from from a solution operating in a hardcore manufacturing environment 24/7, 365 days a year, it's expected to have zero glitches and be extremely robust. And so a little bit about what the platform does is it essentially emulates the operator actions that a normal control room operator would normally do, but while not compromising the equipment protection and the safety system layers which remain in the control system. And that's important to keep those layers separate and in the DCS. Additionally, the platform, it acts as like a referee or a watchdog between the control system set points in the different applications that are in control at any given moment. One example is if you start through some procedure automation with our automatic sequence transition to start up the valve and its control, start up the plant, or use it for decoking and ethylene. It's going to control the set points, but then at some point you're going to transition to steady state, and a new application is going to drive that, say AIPC or traditional MPC, to drive the targets to their max constraints. AOPS Ignite platform will manage all that with error handling. It's very robust and developed. And then third, something to call out for that platform, which is why this platform is integral to our solutions and suite, is that it acts as a unified backbone to integrate our solutions into the existing architecture with like a plug and play, because we can connect with the DCS systems such as Honeywell, Yokogawa, Foxborough, Siemens, all the big DCS manufacturers. Let's say you have a traditional applications such as Aspen or Pace. We have standardized integration kits to plug and play and optimize our solution with your current architecture. So a couple of the modules which Rajeev, he already mentioned, that make autonomous operations possible is the automatic sequence transition. That's procedural automation or state-based control, essentially embedding the plant operating discipline along with repetitive control room operator actions, and even some real-time decision-making logic can be automated and put into the control code to move the process to a desired state, and then monitor that state for any transitions that it needs to go to. So that's integral. Also, the AIPC or MPC, this performs automated plant load changes, and it also automates our steady state targets here. I'll talk about that a little bit, how our self-learning neural network, why we decided to develop that and how it works. And then depending on the solution, you could have real-time optimizers for multiple plants, economic constraints, product demands, varying loads, and the asset performance tools. So that's what I wanted to talk about with this. And now I'm moving on to AIPC. So I've been asked actually quite a few times is why did a supplier or an operator decide to develop their own AIPC software? And the answer for us seemed really simple. To be market competitive in the current global economy, it's critical to address the challenges and unlocking value in an innovative way and invent. And with the advent of AI technology and the challenges that we face, we decided that the development was the right choice for us. And so our processes, they exhibit highly nonlinear behaviors. They also have a very large operating envelope, where sometimes we're at 40%, 60%, 100% for a variety of reasons. So the operating envelope that we have to operate in can be challenging. And we also experience limited availability of APC or experienced practitioners for model predictive control to engineer new solutions, but also maintain the footprint of our existing solutions when plants change or things in the plant change or different models are needed under different operating envelopes. That engineering expertise, we can't just send all of our limited resources to everywhere to maintain these models. And AIPC solves those solutions for us. And I'm really excited to be implementing this. We're excited where we're at today and to implement it in more and more facilities, not only with our own plants, but also for our industry partners. And go ahead to the next one. So AIPC versus classical MPC. For us, it's and for the software, it really boils down to the engineering involved and the step testing. And for the model development for conventional MPC, the traditional way to approach that is through step tests. And that can perturb the process, it can disturb the process, it can create variability, especially if you're at high rates. Or whatever's going on, there may be not ideal to do those step tests. So AIPC, we can do offline model training with existing data. It also has lower expertise and the ability to control nonlinear processes with self-learning neural nets. With the AIPC, we find a superior. So next, I would like to talk a little bit about how the AIPC being self-learning, which is very promising, I want to give you an idea of how that works. And so the solution that we have developed at Linde has two components. And the bottom component that you see on the plant site, that's on-prem. That's the controller. That's what's calculating the optimal set points. And then it's sending it through the AOPS Ignite platform and through that robust platform. And then that sends it down to the DCS. At the same time, the model training component, which is enabled and sits in the MCube, the TCG's MCube platform there, the model training component's receiving data and looking at the operations continuously. And so to walk through that top model training platform there, the data pre-processing step is very important to remove bad data analyzers that are out, instruments that are out, operate units that might be out for extended times and you might need to remodel. You remove that data from the model and then you use the operational data that's at steady state to develop your new models. And so when you do model training, Linde has an automated model training technique where it validates these different models based on predefined test scenarios. And so what you see here in the model validation step here is that based on those test scenarios, it scores them and it also will flag them. And what you then do with those models, or what the model training platform does, is it does have the ability to continuously just iterate itself and do this without any human interaction. That's not what our platform we're allowing to do at the moment. That's not the direction that we're doing with it. That's not what management has decided. We want an experienced, knowledgeable, qualified person trained in this software that we can train and work with them to select the right model and then push that down so that you have the updated optimal model running the plant for the current conditions. And so, Rajeev, I want to invite you to ask to see if you had anything else to add to that.
Yeah, Daniel, I mean, one thing I would like to say here is this architecture allows us to deploy the AI plant controller very fast. Because the initial model can be developed based on the historical plant data, and which most of the brownfield projects will have the historical data. We can get that, develop the model very quickly and deploy it. And once the model is deployed and AI plant control is deployed, this whole cycle starts. What we have seen in the beginning, the model training occurs a lot faster, maybe sometimes every week or sometimes twice every week. And then as the model learns about the process operations more and more, the frequency of this training gets reduced. So that's pretty much I wanted to add, Daniel. So.
Thank you. Thank you. And so moving on to the next slide, please. So a lot of folks say it's just a black box, but the solutions that we have, we give insights into what the model is going to do, what the individual models look like, and the quality of those, so you can get insight into the black box per se, so you can feel confident that you're able to not only look at the model and push it down, but you're also able to look at the individual components. So we have a variety of tools for offline modeling and to look at the step response plots to confirm that, yes, it's going to go in the right direction. It's going to do what I want. I feel comfortable in that based on scoring and the tools available. And so you can delete relationships. You can also update them and remodel them to further get a better model and fit it. That's all I'd like to talk about for this slide. And then I want to invite all the participants here. I have two questions related to model predictive control, and I would like to hear your responses on those. Okay, we have a very good mix. Okay, few with no knowledge, a lot of folks aware, most familiar, and then we got some super experts and some knowledgeable folks. It's a good mix. Okay, and then I have one more question. Okay. Oh, don't know, not applicable. So we got a lot of engineering folks, and majority were in some of the refinery, oil and gas industry. Okay, heavy use. Implemented, most of the folks are implemented in some process units. Interesting mix here. Okay, thank you for allowing us to ask you a couple of questions there and pull that. Now, what I'd like to do is I'd like to hand over to Rajeev, and Rajeev will talk more about the journey and a few other things here related to the AIPC. So please take it away.
Thank you, Daniel, and thanks everybody for answering these poll questions. Just as stated earlier, like Linde started our journey about AI plant control 4 years ago in 2021. We deployed our first AI plant control on a smaller air separation unit. And then each year we have been deploying AI plant control at a bigger plant and more complex operations. So far we have deployed 5 AI plant controllers in the 5 plants, and the 6th one is in progress as we speak. And each year we have deployed this at larger and larger process plants with more and more complex operations, especially some of the steel plants where we have to ramp down and ramp up the production without impacting any quality. So AIPC has proven very successful, and we got really very impressive results so far. Just to give how AIPC functions, like it shows comparison of this graph on the top shows the operation for 5 days without AI plant control. So this is like using the advanced regulatory control in the control system. And when we turned on the AI plant control, you can see how tight the control is, allowing basically lesser utility and power consumption and improving the yield. We also have a very intuitive operator interface. So AOPS Ignite platform hosts multiple applications such as automatic plant startups, AI plant control, and many others, but it uses a single operator interface. And this is just an example of how an AIPC plant, the operator interface for both operators and engineers would look like. And this is the last slide I would like to summarize. The AI plant control is the next generation of process control. It's self-learning. It learns from the operating data and continuously updates the model, and hence, as the plant ages, there is no need to do any step testing because the model always stays up to date. And it has allowed us to improve the plant efficiency and reduce the power consumption between 2 to 10%, and significantly allowed us to reduce the maintenance effort in maintaining these applications. With that, I have one last question for the audience, and we'll just open it up, and then we can go to the question and answers. Well, that's excellent. It's very encouraging to see many of you are very interested in deploying this technology in your plants, and and some of you are not sure, and I understand why, and we are here to resolve that anxiety. But excellent results, and with that I will hand over to Aditi to see what questions we have from the audience.
Thank you so much, Rajeev, and our speakers. It's been quite a compelling session and some really encouraging results that you shared from the implementation. So we have a few questions from the audience. Let's go through those. The first question is, can AI plant control be deployed on brownfield facilities with legacy DCS or PLC systems, or does it require new instrumentation?
Okay, I can answer that. Excellent question. So all our AI plant control deployments so far have been on the brownfield projects. It does not require any brand new system. It works with the existing DCS. The AOPS Ignite platform has interfaces with the DCS, and it connects to the DCS, allowing AI plant control to control. And this AOPS Ignite is a very robust platform. So it works with your existing control system.
Great, thanks a lot for that, Rajeev. The next question, let me see. Is this a closed loop real-time optimization and control tool?
That's again excellent question. Yes, absolutely. This is a closed loop optimization. So basically, in AI plant control, you can enter an objective function. What is the objective of AI plant control? Sometimes, like in air separation plants, we have to maximize the liquid. Some plants have to maximize the gas. In other cases, there could be changes in the feed. So you can enter the costs of different streams and products, and enter the objective function, and AIPC will try to optimize based on your function, and calculate the optimum set point, send it to the DCS, and that's how we achieve the optimized control of your plant.
Okay, perfect, Rajeev. Well, the next one is, what is the maximum frequency by which plant data can be ingested and processed by the MQ platform? So maybe Arunava, you can take that question.
Yeah, sure, Aditi. It's a very contextual and relevant question. So the platform, MQ platform, is designed to handle very high throughput of data, and near real-time synchronization can be achieved through, of course, the right infrastructure sizing and deployment. As per our experience, we have handled as much as 10,000 to 15,000 tags per minute coming from historians and sensors. I hope that answers the question, Aditi.
Thanks a lot, Arunava. The next one, there was something mentioned in one of the slides regarding AOPS and functional safety. What functions may be deployed?
Yeah, that's again a good question, and I think that's basically our architecture slide where it says functional safety. So AOPS is not a part of any functional safety, but to achieve the autonomous operation, what we need as a bottom line is a good, robust functional safety discipline and safety instrumented system deployed at the plant sites. Without that, we cannot have a peace of mind and to trust all these automation systems and remote operations. So it just to show what are all the components required to achieve autonomous operation. But AOPS Ignite, so typically these advanced applications do not interact with the safety system, because safety system has to work completely independently.
Thanks a lot for that. The next one is an extension of the previous question of if it's a closed loop optimization, because it's the same attendee who has asked this question. So with this tool, RTO is not required anymore, or is this a layer above RTO supporting it?
Oh, okay, yeah, that's a good question. So this is so typically in plants or sites where there are multiple units, either like a refinery unit, and there are upstream and downstream units. So typically AIPC will be functioning at each of the unit as a model predictive control type of an application. And we will need an RTO on top of this if we have to achieve a site-wide optimization or site-wide objective function. So AI plant control also works with, we have a product called AI RTO, and which sits on the top of AI plant control. And typically AI RTO will give the set points or the target values to AI plant control in each respective units, and it achieves the site-wide optimization.
Right. The next one, very quickly, a question regarding model training. How do you handle correlated input data to identify independent causal relations? Do you inform the NN with first principles?
Again, excellent question. Okay. And this is, I would say, one of the strengths of Linde's AI plant control. So the model that is developed using the neural net, using the model training, machine learning techniques, can be supplemented by equation based, or if you already know the behavior of the plant, we can enter the kinetic equations or heat and mass balance equations that will supplement the predictions of the model. So we have this AOPS Ignite, and there is a module called ALC, where all the equations and all the known behaviors of the plant can be entered. And if somebody has a first principle equation, we can definitely leverage that to boost the AI plant control performance.
All right, we have questions still coming in from audience. We are a little bit over time, but we'll just take one final question. Okay, does AIPC work at the unit level only, or can it solve a plant-wide problem as well at the APC level by interlinking individual unit models?
Okay. If I understand, like your question is like in a same unit, can it handle? So for example, if it's a ethylene cracker, there is a cracker, there are separation sections. So typically there's a concept of subcontrollers, we call it the submodel, and each unit that will have a submodel, and one controller can handle multiple models, and they can also handle some interactions. So that's how we handle it. But if they are completely different plants, then a separate AIPC instance is installed at each plant.
All right. There are a few other questions, like I said, but we will get back to you over email one-on-one tomorrow sometime. But thank you so much for putting in the questions. And I had one last question for our panelist, which I'm sure a lot of our audience want to ask. What is the first step, or what is the next step if somebody wants to, deploy AIPC? What would you recommend?
We highly encourage to contact us, and we can do a quick study of your process and provide the feasibility and initial proposal based on the process and estimate, and we'll be definitely glad to work with you. So please reach out to us.
Great. So our audience will receive the contact details of our panelists as well, and a recording of this session. We have, kind of overshot a little bit, but that's because it's been such an interesting and exciting session. So thank you so much to our audience who joined us from all over the world. Thank you to our panelists for making time for this session. With that, we end this webinar. So we'll have a series with Linde going forward, Linde and MCube, so our audience can look forward to the next webinars. Thank you so much. Have a good rest of your day, evening. Bye-bye.